In this video, we're going to use the previous content and then make calculations, and then from there, make deep insights. So the first thing we need to do is do a Fahrenheit to Celsius conversion. This is something I've mentioned earlier in the semester. We're doing this only because of formulas are going to require us to use degrees Celsius. So just go ahead and introduce this particular formula. I'll apply it and use it later. To find the saturation vapor pressure, which you'll see noted as E_S or E subscript S in the text, the formula is 6.112 times E, which is actually a scientific calculation, something in which you'll need a scientific calculator to do, to the, and then this particular formula here of 17.67 times T, where T is temperature, once again in degrees Celsius, over that same temperature in degrees Celsius plus 243.5. And whatever that number, then you then do e to the essentially an exponent. It's something in which you'll do using a scientific calculator, one in which you cannot just crank out in your old calculator on your wristwatch. And then the result is in hectopascals, which we symbolize as HPA. To find the actual vapor pressure, which we label as E, it's the same formula as the saturated vapor pressure, just substitutes dew point temperature for air temperature. So the same idea, and so same formula, but instead here, notice we have T_D because that's what we use to indicate dew point temperature, where we have T is air temperature. So it's the same idea, has to be in degrees Celsius, so that's once again why we have that earlier conversion at the beginning of this video. Relative humidity, this is an index of how near the air is to saturation, and now we take those previous slides, the actual vapor pressure divided by the saturated vapor pressure, multiply that result times 100, and relative humidity is an index that's always a percentage. Lastly, we'll be estimating dew point. Estimation, why we use the word estimate and we see the squiggly lines of equals, because this isn't a perfectly precise formula. It's really only valid for relative humidity above 50%. So it's something that's it's good for education purposes, but it is not precise, and that's why you see kind of this clarification in terms of estimating instead of calculating. Similar to how med students will sit there and have to diagnose different cases to figure out, well, what's the deal, what's going on. You, as budding meteorologists, are going to be given different cases and try to figure out what's going on there. So your first case is try to figure out the relative humidity on a muggy summer day. And so here we are, July, Indianapolis. This is during the day. Air temperature of 85 degrees with a dew point of 70 degrees Fahrenheit. We need to calculate the relative humidity. And so going back to our previous slides, we know how that's E over ES, or the actual vapor pressure over the saturated vapor pressure times 100. So first off, we've got to find and calculate the actual vapor pressure, or E. And so what we'll have to do is, over here on the left, the dew point temperature we see is 70 degrees Fahrenheit. We have to convert that to degrees Celsius. Once again, these formulas is based on the idea that we're using in degrees Celsius. So we have to use that conversion, and just plugging in the 70 degrees there, we do the formula, and it ends up that 70 degrees Fahrenheit is equivalent to 21.1 degrees Celsius. So that's our first key step. We then take that and we use that dew point temperature, and we then put that into the formula here. So you can see how the formula is 17.67, then we plug in 21.1, and then we use our scientific calculator. E to the exponent 1.409 gets 4.0, and the end result is, for the actual vapor pressure, is 25 hectopascals. So now we got to calculate the saturated vapor pressure. That's our second step. And to do that, we once again convert. So we have to take that 85 degree overall air temperature, convert it to Celsius. So 84 degrees Fahrenheit is the same as 29.4 degrees Celsius. We then plug that number in. Once again, very similar formula. Only the difference is now we're using air temperature instead of dew point, and we'll get a result of 40.9 hectopascals as our saturated vapor pressure. We take those two numbers to calculate our RH. Once again, E over ES. So we take that 25 divided from it 40.9, and our result is 61%. So an RH of 61% at 85 degrees Fahrenheit feels muggy. And what that does is it pushes that heat index above 90 degrees, which then, of course, is going to raise heat stroke issues, also thunderstorm risks, kind of like those severe storms we saw over the summers regularly in Indiana. Let's go ahead and go to another case. Now let's estimate the dew point in the winter time. So let's picture a cold January day. Temperature is 30 degrees Fahrenheit, and we have a relative humidity that's relatively high at 71%. So let's estimate the dew point temperature. So that's going to be a good indicator of how dry our air is. So to do that, first off, we'll look at our formula. So dew point temperature is the air temperature minus 100 minus RH over 5. So we have our our air temperature at negative 1.1 degrees Celsius. So I would have done that conversion, and then from 30 degrees. And then we have our RH at 71%. Just plug that in there. And so you then put those numbers together. 100 minus 71 over 5 is 5.8. Negative 1.1 minus 5.8 is equal to a dew point temperature of negative 6.9 degrees Celsius or 20 degrees Fahrenheit. When you have a dew point of 20 degrees Fahrenheit, that is very dry air. And when you heat it indoors to, let's say, 68 degrees Fahrenheit, the relative humidity is going to drop even further, causing even drier air, chapped skin, and static everywhere. When you touch things, you get static, which you often find in Indiana winters. Now let's look at how the relative humidity changes over a summer day with a constant dew point. So we're going to keep the dew point the same throughout the entire day. The only thing that's going to change is our air temperature. Our air temperature at 9 a.m. is 70 degrees Fahrenheit, and our air temperature at 3 p.m. has gone up 20 degrees to 90 degrees Fahrenheit. Once again, though, the dew point stays constant. So what we need to do is we need to find out the actual vapor pressure and also the saturated vapor pressure. And we need to do that at different times of the day, of course, since we're looking at relative humidity at 9 a.m., but also at 3 p.m. So let's first off find out that E, or the actual vapor pressure. And that's where we're going to then plug in the dew point temperature, that constant number, which is 15.6. So I got that 15.6, plug it in. And our result of all of that is an actual vapor pressure of 17.7 hectopascals. Now for the morning, let's find the air temperature. We got 70 degrees, which is equivalent to 21.1 degrees Celsius. So as I calculate the saturated vapor pressure at 9 a.m., I will then find the result to be 25 hectopascals. So now if I take the relative humidity formula and then just plug in those numbers, 17.7 from the previous slide and 25 from this one, we get 71% at 9 a.m. in terms of our relative humidity. Now let's look at the same thing but later in the day. So what we have is we have our formula, and our air temperature is now 32.2. And the result of that is 48 hectopascals. So then our afternoon relative humidity, if we take that 17.7 and now divide 48 from it, we get a 37% relative humidity at 3 p.m. So essentially the moral of the story here is even with the same moisture, the relative humidity drops from 71% in the morning to 37% in the afternoon because warmer air can hold more vapor. This is why Indiana summer mornings will often feel stickier than the afternoons. You might notice that if you go for a run, sometimes you might think it might be better to go for a run in the morning because it might be cooler, but the relative humidity might actually be higher. So are you brave enough to test your skills? Let's see if you can do this on your own. September, Naptown, daytime, 80 degrees Fahrenheit, dew point 65. You need to calculate the RH. Now you got April, Naptown, daytime, 60 degrees Fahrenheit, relative humidity is 68%. You can estimate the dew point.